Our brain contains over 85 billion neurons. Neurons come in different shapes and sizes, but this is a standard example of a multipolar neuron. I learned from our textbook that a neuron is similar to an outlet in our house. A charge inside of the cell is known as the membrane potential. And when the charges flow from one area to another, it creates an electrical current. Today I'm going to be discussing resting potential and action potential. Resting potential is when the cell is inactive or at rest. Action potential is a rapid change in the membrane potential. It first begins in a positive direction and then changes to a negative direction, and then it returns to the state of resting membrane potential. This occurs along the axon, returns to the cell body, and then to the axon terminal. Neurons are excitable, which means they can respond to stimuli. So let's get into action potential. So the resting membrane potential starts at about negative 70 millivolts. Then depolarization occurs, making it closer to zero. The neurotransmitters will react with the receptor, and this causes repeated depolarization. And then your neuron will reach threshold. So when you reach threshold, when threshold is reached, a large amount of sodium channels open, and this lets ions into the cell. This causes depolarization of the neuron. It reaches zero, and then it becomes positive, reaching the rising phase is what I call it. So the influx of positive ions creates an electrical signal, and this is known as the action potential, and then it begins to travel down the neuron. So then it'll reach its peak when the sodium channels close and the potassium channels open. And in doing this, it kind of allows the potassium to flow out of the cell. The loss of these ions causes the next step, which is repolarization. I call this the falling phase. So this is kind of where the neuron returns to its resting potential, but it kind of overshoots it. And at this point, this is where the cell becomes hyperpolarized. This is called hyperpolarization. And at this phase in the refractory period, it's really hard for it to fire again. And then after this process, it returns to resting membrane potential, where this can start all over again. It travels down the neuron to the axon terminal, and it can release the signals to the next neuron. Here we've got our dendrites, the cell body, the nucleus of the neuron, the axon, the nodes of Ranvier, the axon hillock, where the action takes place, the myelin and sheath, which covers it, the axon terminal, and then the synaptic knobs. I hope you enjoyed this presentation of the neuron and action potential and resting potential. Thank you for listening.